Hey everyone. Today what we're going to be doing is we're going to be working on grade 4 module 1 lesson 9 problem set. And in this lesson what we're going to be doing is we're going to use place value understanding to round these multi-digit numbers to any place value. So we may be rounding to the nearest 100,000, 10,000, 100,000. Really just sort of depends on our direction. So I'm going to go ahead and hop right in with number 1. It says round to the nearest thousand. So we're going to take each of these numbers here from A, B, C, and D, and all of them are going to be rounded to the nearest thousand. Now, in the last video, what we were doing was we were using that vertical number line to sort of help us out with our understanding with like this top number and then this middle number and the bottom number. We're going to try and kind of move away from this and just try to use our understanding of the numbers and the digits in their respective place values and what they represent. So if I'm rounding to the nearest thousand, the first thing I like to do is make sure that I know what digit is in that place value. So if I'm rounding to the nearest thousand, I should identify the digit in the thousands place. In this case, it's a 5. The next thing I want to do is I want to look at the place value or the digit in the place value just to the right of it. So in this case, it's the 3 there. So I'm looking at this 5 in the thousands place and this 3 in the hundreds place. And really, this digit here in the hundreds place decides what happens to the place value of this number, next to it. So what we always say is we need to think about, is this digit a 0, 1, 2, 3, or 4? If it's one of those digits, then this number in our place value being rounded is going to stay the same, and everything else is going to change to a 0. If it's 5 or above, 5, 6, 7, 8, or 9, that's actually going to bump this digit in the place value being rounded up by 1. In this case, we have a 3 in the hundreds place. So the 3 in the hundreds is not going to be able to bump this 5 in the thousands place up at all. So that 5 in the thousands place is going to stay, and all the other digits just change to zeros. So 5,300 rounded to the nearest thousand is 5,000. Over here to letter B, again, I'm rounding to the nearest thousand, so I should identify the digit in the thousands place. In this case, it's the 4. And then I peek my attention over to the digit to the right in the next smallest place value, or the hundreds place. Now, since this one is a 5, that is going to be able to bump this 4 up to the next digit. So after 4 comes the number 5, and all of these change to zeros. So 4,589 would round up to 5,000. It's closer to 5,000 than it is to 4,000. In letter C, we have a 5-digit number, so we have this 4 here in the 10,000s place. We're just going to kind of leave that as is for right now. That's just coming along for the ride, as I like to say. So we're rounding this to the nearest thousand. This 2 is in the thousands place. I'm going to peek over at the digit next to it, which in this case is a 0. And that 0 is not going to be able to bump up that 2 to the next largest place, or to the next digit. So the 4 in the 10,000 stays as is. 2 is going to stay as is, and all the other digits change to zeros. In my hundreds, tens, and ones are going to become zeros. So 42,099 is going to round to 42,000. And over here we have 801,502. 1 is in the thousands place. Peek over at the digit in the hundreds, which in this case is a 5. Is 5 going to be able to bump up the 1? The answer is yes. 5 or above, we bump this digit in the place value being rounded up to the next number. So the 8 and the 0 stay as is. Those don't change because the 100,000s and the 10,000s aren't going to be affected. The 1 in the thousands place becomes a 2, and all the other digits change to zeros. So 801,504 rounds to 802,000. Letter E says explain how you found your answer for part D. So what was my thinking in doing, letter D right there? Well, we're just going to go ahead and we're going to explain our process. So first, I looked at the 1 in the thousands place. Then I noticed a 5 in the hundreds place. A 5 in the hundreds place tells me to bump up digit in the place value that is being rounded, is the thousands. So the 1 is a 2, the 8 and 0 stay as is. Everything else changes to a 0. That's the process. That's the process for rounding these numbers. Let's take a look at number 2. Same sort of idea with our exercise, but in this case, we're not rounding to the nearest thousand, we're rounding to the nearest 10,000. So all my attention is just going to shift over to the 10,000s place. The process stays the same, the place value in which I'm rounding is changing. So round to the nearest 10,000, letter A is the number 26,000. So since I'm rounding to the nearest 10,000, I identify the digit in the 10,000s place this time. In this case, it's a 2. Now I'm going to direct my attention to the thousands place, and this 6 is going to tell this 2 what to do. Again, if it's 5 or greater, that digit is going to bump up to the next place value, or I'm sorry, bump up to the next digit. If it is 4 or below, it stays the same. So since it's a 6, that tells this 2 to bump up to the next number, which is a 3, and everything else changes to a 0. Since I'm rounding to the nearest 10,000, my answer needs to be a 10,000, which means my thousands, hundreds, tens, and ones place all need to be a 0. The last non-digit 0 in most cases will be in this 10,000s place. Letter B, 34,920. Again, rounding to the nearest 10,000. This 3 is the digit in the 10,000s place, and I peek over at the digit in the place value to the right, which is a 4. Now, 4 or below, we're going to leave this digit in the 10,000s place alone. We're not going to take it down by 1. We're just going to leave it as is. So it's going to stay a 3, and all the other smaller place values change to zeros. So 34,920 rounded to the nearest 10,000 is 30,000. Letter C is a 6-digit number, but my process is going to stay the same. Identify the digit in the place value being rounded, which is this 8 in the 10,000s place. Take a peek over at the next digit to the right of it. Since this is a 9 in the thousands place, that will be able to bump this 8 up to the next digit, which is a 9. My greater place value stays as is, so 7 in the hundred thousands, 8, 0, 0, 0, 0. So 780,000. Last but certainly not least, we have 706,286. So 0 is in my 10,000s place. 6 is in my next greatest place. My next smallest place value. So this 6 will be able to bump up this 0 here. So 7 in the hundred thousands place stays the same. Since there's a 6 in the thousands, the 0 in the 10,000s becomes a 1, and everything else changes to a 0. Letter E says, explain why two problems have the same answer. Write another number that has the same answer when rounded to the nearest 10,000. So what they're referring to here is my answer in A and my answer here in B. So what's neat is the number 26,000 rounds to 30,000, and the number 34,920 also rounds to 30,000. So we're going to have to talk a little bit about what happened in letter A and letter B. So in letter A, 6 in the thousands place made you round up to 30,000. In letter B, 4 in the thousands made me round that number down to 30,000. Let's write another number that has the same answer when rounded to the nearest 10,000. So there's a couple different ways that I could do this. I could either have a digit of, a 2 here in my 10,000s place, and these digits over here in the hundreds, tens, and ones really don't matter. Okay, but what I would need to do is I would need to make sure that this number here is a 5 or greater. A 5, a 6, a 7, an 8, or a 9. So let's just use maybe like a 7 or something. Okay, so that 7 would bump this 2 up to a 3 and round to 30,000. The other thing I could do is I could put a 3 here in my 10,000s place. I'm going to leave my thousands place blank. And again, hundreds, tens, and ones numbers don't matter or aren't going to affect, what happens. So 295, whatever. These digits can be whatever you want them to be. But this digit here in my thousands place needs to be a 4 or lower. That's going to make us round down to 30,000. So let's just put a 1 here. So 27,367 would round up to 30,000. 31,295 would round down. Again, the real key here is what digit is going to go in this thousands place. That's either going to force you to round up or force you to round down. Let's take a look at 3 A, B, C, and D here. And this time we are rounding. Change my color really quick. This time we're rounding to the nearest 100,000. So again, process is the exact same. The only thing that's changing is where we are looking, right? So I'm rounding to the nearest 100,000. Find the digit in the 100,000s place. In this case, it's an 8. Peek over at the digit in the 10,000s place, which in this case is a 4. Excuse me. So this 4 is not going to be able to bump this 8 up. So we're going to leave this 8 as is, and all these other digits are changing to zeros. So 840,000 rounded to the nearest 100,000 is 800,000. Letter B, I have an 8 in my 100,000s places again, but this time if I look over at my 10,000s, there's a 5. Now with a 5, that means that I'm going to have to bump this 8 up to the next number. So this 5 is going to change this 8 to a 9, and all other digits change to zeros. So 850,471 would round up to 900,000. Again, 5, 6, 7, 8, or 9 in the next smaller place value will bump the place value that you're rounding up by 1. Letter C, I have a 7 here in my 100,000s. The number is 761,004. And peek over at my 6. Now 6 is going to be able to bump 7 up to the next number. So 7 plus 1 is 8 in my 100,000s place. And all my other digits change to 0. So we have the same answer for A and C. Now letter D is one that's a little bit tricky because here I have a 9 in my 100,000s place, and this 9 in the 10,000s place is going to tell me to round up. So what comes after 9? The number is 10, but if we recall from, I think, maybe like lesson 1 or lesson 2, what happens is when I have 10 of one place value, that's equal to 1 of the next greatest place value. So I'm actually going to have a 10, 0, 0, 0, 0, but I'm going to sneak another comma in here, and this is going to actually be 1 million. So 10 100,000s is equal to 1 million. Remember, 10 of one place value is equal to 1 of the next biggest place value. So 991,965 rounded to the nearest 100,000 is actually 1 million. Letter E is very similar to 2E. Explain why two problems have the same answer. So here's the two examples with the same answer. Write another number that has the same answer when rounded to the nearest 100,000. Well, our explanation is going to be fairly similar. So explain why two problems have the same answer. Well, 840,000 would round down to 800,000 because of the 4 in the 10,000s place. 761,004 would round up to 800,000 because of the 6 in the 10,000s place. So in letter A, we rounded down, and letter C, we rounded up. Now, sort of the same idea as this last example here, where I need to write another number that has the same answer when rounded to the nearest 100,000. So what number would round to 800,000? And again, there's two ways you can really go about this. Do you want a number that's going to round up to 800,000, or do you want a number that's going to round down to 800,000? It's, really up to you. If you want it, let's say we're going to round up to 800,000 here. Well, I'm going to probably use a 7 here in my 100,000s place. And just like letter C, I need to make sure that whatever digit is here in the 10,000s place would round the 7 up. So this needs to be a 5, 6, 7, 8, or 9. So we used a 6 in letter C. Let's use an 8. And again, whatever digits you use in the thousands, hundreds, tens, and ones aren't going to affect your answer. So 3, 2, 1, 0. Okay. What's really important is this digit here in the 10,000s. Now that would round up to 800,000, but if I wanted to round down to 800,000, I would use an 8 here in my 100,000s place, and this digit in the 10,000s is the important one. Now we need to make sure that this is either a 4, 3, 2, 1, or 0 in order to round down to 800,000. So I'll use a 2. And again, thousands, hundreds, tens, and ones, whatever digits in there is not going to affect our answer. So I could use all 9s really. 9, 9, 9, 9. It's not going to affect my answer. Number 4 says solve the following problems using pictures, numbers, or words. The 2012 Super Bowl had an attendance of 68,658 people. If the headline in the newspaper the next day read about 70,000 people attend Super Bowl, how did the newspaper round to estimate the total number of people in attendance? So, how do 68,658 people actually attend, but then the newspaper headline reads that there were 70,000 people there? Well, the easy answer is when we're using, these round numbers in real life, we don't really say there was an actual attendance of 68,658 people. Maybe on the Jumbotron they'll show exactly how many people, but most people who are reading the newspaper or reading an article, they just want an easy number to work with. So how did the newspaper round to estimate the total number of people? We would say the newspaper rounded the total number of people up to the 10,000s place. 68,658 when rounded to the nearest 10,000 would be 70,000. See, we have an 8 here in our thousands place, and that would bump up this 6 to a 7, resulting in the number 70,000. Letter B says the 2011 Super Bowl had an attendance of 103,219 people. If the headline in the newspaper the next day read about 200,000 people attend Super Bowl, is the newspaper's estimate reasonable? Use rounding to explain your answer. And I'm just going to take a second to really talk about this word reasonable. And when you read this word reasonable in a word problem, what I want you to think is, does it make sense? Is that estimate reasonable? Is it make sense to say that 103,219 would round in any capacity to 200,000? And the answer would be no way. Absolutely not. Because if I go by the rule of rounding here, I would look, it seems to me that we're rounding to the nearest 100,000 because 200,000 is a form of 100,000. And I would look at my 1 here and I should peek over at the 10,000s place and the digit that's in the 10,000s place. This 0 will not be able to bump this 1 up to a 2. There's no way. In order for that to happen, this would need to be either a 5, 6, 7, 8, or a 9 to be even closer to 200,000. So 103,219 is not close to 200,000. It's closer to 100,000. So, does this make sense? The answer here is no. Does not make sense. Okay? Use rounding to explain your answer. So, we could say the estimate is not reasonable. Pause. 103,219 would not round to 200,000. It would round to 100,000. 100,000 is the more reasonable estimate. It would make more sense to say that about 100,000 people attended the Super Bowl, not 200,000. And letter C says, according to the problems above, about, so again, when I read that word, I should recognize that I'm going to be rounding or estimating in some capacity. About how many more, that's a big key phrase in math as well, people attended the Super Bowl in 2011 than in 2012. Round each number to the largest place value before giving the estimated answer. So in letter A, my number, let me just go back and double check, 68,658 people. Okay, now that tells me to round each number to the largest place value. Let me just quickly do letter B first. In letter B, the number was, I have it right there, 103,219. So when it tells me to round each number to the largest place value, that means the largest, the digit in the largest place value in the number provided. So in letter A, that 6 is in the 10,000s place. So in letter A, I'm going to round to the nearest 10,000. And 68,658, we sort of already did this, would round up to 70,000. And in letter B, again, we sort of already did this as well. This would round to 100,000. Now, when it says how many more, that's a keyword to subtract. Almost always when you read how many more, that means that you need to subtract. So 100,000 minus 70,000. Make sure you line up your place values. And 10 minus 7 here is 3. So about 30,000 people. There were about 30,000 more people in Super Bowl from 2012 than there was in 2011.